Right now. All right, so we're going to change gears a little bit. I don't know if you remember, but the title of this chapter was Probability and Statistics. And so I'm not saying we're done with the probability part, because we're going to see that again, of course. But we are going to sort of pivot towards the statistics part of the chapter. So this section is on analyzing data. You did this all in like 8th grade pre-algebra, so it's going to be easy peasy for you. Today we're going to calculate some measures of central tendency. Does anybody remember one measure of central tendency? Yes. Mean is one of them.
Median.
Yep. Mean, median, mode, range. Good. So you guys are going to do really well with this. We'll just sort of think of it as a maybe an end-of-year review. Maybe we'll get a little bit more in depth than you have before. I'm not really sure. What is the mean? The average. Hopefully you guys. Again, please stop interrupting. Yeah, the mean is the average. Hopefully you guys all know the formula for that. You just add up all the numbers you have and divide by how many numbers there are. The median is the what? Middle number. And that, of course, is when they are listed from smallest to largest. So it's not the middle number just necessarily as they're written. You sometimes have to rearrange them. The mode is what? Most common number.
Well, what happens if it's 1, 2, 3, 4, 5, 6, 7, 8?
Then there's no mode. Yeah, right. So if none of them come up more than once, then there is no mode. And if some of them come up multiple times, but it's the same amount, then it's bimodal. Okay, and then the range is largest number minus smallest. Okay, so yeah, you guys have studied all of this before. I don't know if you have figured this out yet, but the way math is taught in this country, for better or worse, is it's a spiral. So you keep sort of going back over the same topics again and again, but in theory, each time you revisit a topic, you do it like in a little more detail, a little more depth. All right, so yep. All right, so that's what we just talked about. Those are all measures of central tendency, mean, median, and mode. We've talked about this also. Bimodal data has 2 modes, no big deal. No, I think if you have more than 2, then you say, then you just don't say it. If a data set has more than 2 modes, then the modes are probably not useful. So,
no mode.
Yeah. Depends on what the question is asking. All right, so let's do an example. The frequency table shows the number of job offers received by each student within 2 months of graduating with a mathematics degree from a small college. What are the mean, median, and mode for the job offers per student? So we have to actually do a little bit of work here, because 2 students got no job offers, so that means I have to go 0 and 0, right? Because there were 2 students that didn't do very well. 2 students got 1 job offer, so there's actually 2 ones there. 4 students got 2 job offers, so there's 4 2s. 5 students got 3 different job offers, and oops, that's only 3. I got confused. And then 2 students got 4. So that's actually our data set. So that's something that's called a frequency table. It's not all of the numbers just listed out like you're used to seeing them. It's the different numbers that are available and then the frequency that each occurs. Okay? So how would I figure out the mean? Right, I would have to add all these up, right, and then divide by the number of students. But since multiplication is repeated addition, you can do it in a shorter way by multiplying these all together and then dividing that. So 2 times 0 would be 0. 2 1s is 2. 4 2s is 8. 5 times 3 is 15. and 2 times 4 is 8. So that's the total number of job offers that there were. How many students are there? 15 altogether, because 2 plus 2 plus 4 plus 5 plus 2 is 15. So 10, 25, what is that? 33 divided by 15. So on average, each mathematics major, nice job, math majors, got about 2.2 job offers within 2 months of graduating. Yeah. So be a math major. Okay. I was a math major, yeah. Okay, so the median then is the middle number, right? So how do you guys like to do that? Okay, yeah, okay, I kind of like to do that. Do the start on the end and then just count your way in. Okay, so the middle number is 2, okay? The other way that you can do it is you can go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I guess there are 15 students, so there's 15 numbers. There's 15 numbers here, so that means there's going to be 7 on each side, right? So if you don't want to do the double counting thingy, you can just do that and then go 1, 2, 3, 5, 6, 7, and so this would be the median right there, because there's 7 numbers. Ooh, great question. Yeah, then you take the average of the 2 middle numbers. Okay, so for example, Colin, if we had another number out here, then we would go to the middle 1, 2, 3, 4, 5, 6, 7. I don't know what just happened there. Was it really that funny? There we go. So we would meet at the 2 and the 3. So the median would be 2.5. Because the average of 2 and 3 is 2.5. Okay, good question. Okay, and then the mode, what's the most common number of? 3, and that's easy to see from this frequency table because that's the highest number of students that received, or the highest number of job offers. So that one's going to be 3. Okay, so easy stuff, yeah? Yeah, okay. Okay, so we don't need to do another example of that. Okay, so let's talk a little bit about an outlier. An outlier is a value that is substantially different from the rest of the data set. And the reason why these are important to recognize is because they can have unrealistic effect on the mean and the median and the mode. Okay, so for example, if you were to look up or calculate the average annual salary of geology graduates from the University of North Carolina, it might be like $2 million a year, okay? And so you might look at that average and you would go, wow, I'm going to go to the University of North Carolina and be a geology major because they make a ton of money. But there's one geology major from the University of North Carolina who is particularly wealthy, not Bill Gates, not Donald Trump, Michael Jordan. And so his salary pulled everything else up. And so it gives an unrealistic example or whatever average of what that salary would be. So a lot of times what you want to do is you want to figure out things that are outliers. I don't know, I just kind of made that up. And then throw that out, okay? This happens to me when I watch sports. This bothers me, and I know this is just me being a math nerd, but I am a Minnesota Vikings fan because I grew up in Minnesota, and Minnesota Vikings have a really good running back, Adrian Peterson, and Adrian Peterson is known for rushing, no, it was his kid, 2 yards, 1 yard, 2 yards, 3 yards, and then he busts out like an 80-yard touchdown run, okay? What's that? No, it was his kid. It was with a switch, with a branch. Anyway, not important for this conversation. So when you look at those numbers, when you're watching the football game, they have a little statistic down there, and they say average yards per carry. And then his average yards per carry, look, yeah, it looks like, 7.2 yards a carry or something. And so you're like, well, why don't they just give him the ball every time? But that's because he had one really big one, and then all the rest are relatively small, right? Yeah. Because they stack the line against him, and if he can bust through the line, then all he's got is the secondary, and then touchdown Vikings. Anyway, so it's important to know what the outliers are because you can throw those out and then you get a good look at the data, okay? So are we not going to, okay, I don't know if we're going to get into the, there is a formula for this.
Wait, we're basically going to Box-and-Whisker.
Okay, there's a formula for deciding whether something is an outlier or not, and so I don't know if we're going to get into that or not, but just to sort of familiarize yourself with the concept, which number here seems like it doesn't really fit in? Yeah, the 98 is way outside of all of the other ones, so that would be an outlier, okay? Okay, the range we talked about already is the highest and the lowest. And then, or the highest minus the lowest, and then you can take the things and the median divides it into two halves. And if you take the two halves and divide them into halves, then those give you what's called the interquartile range. Nothing. Okay, so let's take a look at this right here. This shows the average monthly water temperatures for 4 locations on the Gulf of Mexico. It says, how can you compare the 12 water temperatures from St. Petersburg, Florida, with the 12 water temperatures from Key West? And so what are some different ways we could do that? Anyone? How could we, what would be a way that we could statistically compare the average water temperatures from St. Petersburg with the ones from Key West? Okay, so one way is we could find the average of those things, okay? What's another way that we could do it? Okay, we could look at the median. We could see which one was the middle number, the highest or lowest. What else? We could look at the range or something like that. Okay, so the nice thing is a lot of these problems you're dealing with big data sets like this. Your calculator has a way to do this all very, very quickly. So if you have a graphing calculator, will you get it out right now? And if you don't, you might want to grab one so I can show you a way to save yourself some time. Mm-hmm. Mm-hmm. Will you, Hannah, can you pass that to Sam for me?
What shirt are you wearing?
Okay, so here's how this goes. Ready? Ready? You're going to hit the stat button first. Okay, Josie, hit the stat button first right here in red.
Wait, where?
The last key that I hit on the screen is highlighted in red, so it's easy to find. And then I'm going to hit enter. Okay, so that takes me to this list section. We are going to take all of the data and enter it into L1 and L2. Okay, now you probably already have some data in those lists, and so the first thing you have to do is clear that out. So the way you clear that out is you go all the way up to the top of the list heading and then hit clear. And then when you scroll back down, all of that is gone. And then I'm going to do the same thing for L1. Okay? So my L1 and L2 are now both empty. No, because I'm only going to compare St. Petersburg and Key West, so I only need 2 columns to be empty. Okay? It clears when you scroll back down. Okay? So go back, yeah. Clear, not delete, clear. Okay, Bailey, you have your book open. Would you mind reading me the temperatures for, oh, okay, Hannah, you got it? Okay, so now we're just going to type them in. So 62, 64, what?
68.
Uh-huh.
74. 80. Wait, am I reading the Florida one?
You're reading the, yeah, the St. Petersburg, Florida, the first one. Okay.
And then 86, and then 86 again, and then 84, and then 78,
70 and then 64. Okay, so those are all of those numbers in there. Then if I go over to L2, now I'm going to type in all of the average temperatures for Key West.
70,
Wait, I screwed up. 70, 75,
78, 82, 85, 87, 87, 86, 82, 76, 72.
Okay. No, we don't. We just needed those first two they asked us to compare. Okay, so you have all the information into L1 and L2, right?
No.
Yes.
Yep. What do I do now, Senorita?
Okay, so now I'm going to go second quit to go back to the home screen.
Wait.
Second mode, second quit, and that gets me back to the home screen, okay? And I'm going to first have the calculator tell me what the mean and the median and the mode and all that of each data set is. That's really easy. Hit the stat button again. And then this time go over to calc because we're going to do some calculations. And you want to choose option number one variable stats, okay? So some of you get this screen depending on what operating system you have. Some of you just get a thing that says, I'll get you there in a minute. You want the list to be L1. The lists are above the numbers. So number 1, if I went second 1, then that would type in L1 for me, okay? And I don't care about this, and I don't care about this, so I'm just going to hit calculate. So you guys just hit enter if you didn't get that screen. And then here's all the information that we need. This first thing right here is the average. The X with the little bar over across the top is the average. So this is for St. Petersburg.
How do you know what's what?
I'm telling you. I know because I'm a teacher and I'm telling that to you. Okay? So the average for St. Petersburg is the X with the little bar on the top is 75. This stuff we are not going to get into, I don't think, in this class. That's the standard deviation and the variance and stuff like that. But it also gives us the minimum, the maximum, and then if you scroll down, it tells you the other stuff, the minimum, the first quartile, the median, the third quartile, and the maximum, okay? So I can write those down also. So I'm going to go min, Q1, median, Q3, and maximum.
It says min X. Is that
Yeah, the minimum X value was 62. And the first quartile is 66. The median is 76. The third quartile is 84. And the maximum is 86. Okay? Median. So this is the middle number right here, 76. This is the lowest and this is the highest. And then Q1, this is the middle of the low half. And then Q3 is the middle of the upper half, okay? So now let's do the same thing for Key West. And so we need to tell the calculator that this time we want it to use the numbers from list 2. So I'm going to do the same thing over again. I'm going to go stat, calc, and I want the very first one. But now we need to have it say L2. You guys don't have this, but you just need to just change it to L2 also. So go second 2, and does a little L2 show up at the end of the one variable stats? Okay, so now when you hit enter, it's going to do the same thing, but it's going to be for the other data set. Okay, does that make sense? So the reason you didn't have to type anything in the first time is because the default that pops up is always list 1. So if you want to do anything besides list 1, then you have to tell it, okay? So for this one, the average is 79. The minimum was what? 69. What was the first quartile? 73.5. I'm not trying to ask hard questions here. What's the median? You guys should have this on your calculators. What's the median? Whoa. What's the median? 80. Okay. How about the third quartile? 85.5. And the maximum was 87. Okay. So looking at these numbers, what do you notice? How would you compare them? Key West wins in every category. It's got the highest average, higher average. It's got a higher minimum, higher maximum, higher median. Everything about it is warmer. Okay. So all in all, Key West water temperature is hotter than, warmer than St. Petersburg. All right. Okay, so you can take those things that we just made and make a box and whisker plot out of it. This number right here, this bar in the middle goes with what?
Median.
The median. These, the end of the box is defined by what?
Quartiles.
Right, the quartiles Q1 and Q3, and then the whiskers go out to the minimums, okay? So if I was to go back to St. Pete's and make a box and whisker plot. What's my, let's say if I go from the bottom is 60, the top one looks like it's 86, I'm going to go to 90. So hold on, 70, 80, and then we'll go 65, 75, and 85. Okay, so for St. Petersburg, the median was 76, so I put a vertical line right there. The first quartile was 66, so the end of that box would be right there. The third quartile is 84, so that goes right there. So that gives me my little box. Okay? So half of the numbers are inside that box. Then my minimum went down to 62, and the maximum went up to 86. And so that's what my box and whisker plot would look like for those numbers. Okay? You can also do box and whisker plots on this calculator, but it's not really that great of a deal. Okay? Okay, so we did that. All right, and then the percentile. This is a number that some of you maybe know already, because if you took the PSAT or the SAT test, you were given a couple of numbers that are your raw scores. So maybe you got a 650 on the math and a 500 on the English. But the number that's probably the most important is the percentile that it gives you. The percentile tells you what percent you did better than. Okay? So if you're Nate and you took the PSAT in the math, 99 percentile, were you? Yeah, okay. So he's better than 99% of the people. No one can ever be in the 0 or the 100th percentile. Why? No. If you were in the 100th percentile, then that means that you did better than 100% of the people that took the test, including your own self. So you can't ever do better than yourself, so you can't actually be in the 100th percentile. Same with 0. You might be in the 1 percentile. You might have only, but you can't do worse than your own self did, okay? All right, so this is really easy then to figure out. Here's an ordered list of midterm test scores for a Spanish class. What value is at the 65th percentile? So how many numbers do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 numbers. What's 20 times 0.65? Because they want the 65th percentile. So I'm changing that to a decimal. 20 times 0.65 is 13. So to be in the 65th percentile, you'd have to be better than, not the 13th number, but better than 13 of the numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if you got an 88, you would be better than these 13 test scores, which is 65% of the data, so you'd be the 65th percentile. Does that make sense? So you want to be one after that, okay? Okay, works for me if it works for you.